Okay, week 5 homework. This is how we will hand it in. We will first open up a border template. Now, we're going to use the border template for the evaporator cover, which is in inches. So open up this one. It should say English down the bottom. We're going to put both of week 5's pictures on here. Even though the airfoil is in inches, we're just going to show that as an isometric. So let's bring in the airfoil first. And it should come in kind of large because it's the wrong units. And let's see, we're going to bring it in as an isometric. And let's shrink it down. And let's rotate it so I can see that it's hollow. 90 degrees. There, that orientation. And we're just going to stick it up here in the top. And we'll make it hidden lines invisible and shading fully shaded. Yours should be similar. Either cut a hole out of it or pierce through the side so I can see that you did the what I'm doing here is I want you to verify with this isometric that you used the through curves command correctly, that the part looks right, okay, and that it's shelled out, so that you did the shell command. And you should play with those two commands a little bit. You know, try to make a bottle or something with like circles, stacking circles on different elevations, and then meshing through or through curves, okay, and make a table legs or a vase or something. You know, play with the commands a little bit so you get familiar with them. The through curves, what people usually mess up with is they forget to say add a new set of sketches. Okay, add a new set. So you got to choose one set, click add a new set, and grab the next one. Okay, so that's all we're going to do for the airfoil. Just going to stick it up there in the corner. Then we're going to bring in the evaporator cover, and that might be a little bit big. Remember, it always comes in as a top view in the orientation you modeled it. That might be a little bit small, so let's go ratio. You always want to make the parts as big as possible since we're only on small paper here. That's the wrong way. Okay, I want to go 1 to 1.5. Okay, so that would be like the top view, and that would be a front view. And if we did a right side view, add project, right click on the boundary, and you can add a projected view. Now take a look at these three views. Is there anything that this view has that this view doesn't have? This is the worst view. Everybody agree? We don't need this view. It doesn't give us any more information. Okay, this view we can show the radius. If we had to dimension this part, we'd have to use this to show a dimension on. This view we don't need, so we're going to delete it. Put in your titles. Top view. Close that. And front view. Or at least call it front. And these should be all uppercase. In industry, all text is uppercase. Why is it uppercase? Well, if you want to know, back in the day, whenever we made copies of prints, we didn't have full-page printers. So what we had to do is use blueprint machines. You've probably heard of blueprints. Blueprints were a way to transfer media. Blueprints weren't very high resolution, so text was sometimes hard to read. So they had to come up with standards. Text was 5/16 of an inch tall, or 9 millimeters tall. They're almost equal. So that was the standard. Text had to be so tall. Okay, 9 millimeters tall. And because of that, you couldn't have upper and lower case. So they just said all text will be uppercase, so it's readable when we get fuzzy prints. So that's why. Nowadays, there's no reason to stick with that. It's just sort of standard, But I see people, using upper and lower case now, but let's stick with standard. So we'll put in front or front view, whichever you prefer, and all uppercase. We will stick with the standard of uppercase. Yeah, technology is changing, and that probably is being ignored more and more. Base view will bring in evaporator cover again as an isometric. And we'll scale it down. Now, some people for week 4 always make this mistake, and they say, hey, you know what, I can just project from this view and it gives me a 3-dimensional view. Although that view looks 3-dimensional, it is not 3-dimensional. It is not an isometric. Remember, an isometric has a vertical component. So like these center lines of right here should be vertical. This is a 2-dimensional drawing looking in this direction. It is a 2-dimensional drawing looking in that direction. It is called an auxiliary view. We'll get to that in week 8, but that is not an isometric view. And you can't dimension straight in it. Click and drag around that, hit delete, and all the center lines go away. You should not see an edge view here. This should be tangent. Now, for center lines, it always puts in center mark center lines. We're going to get rid of those. There are 2 ways to dimension holes. There is a rectangular coordinate system where you could dimension from the center X and Y to each center of all those holes. You can see that putting dimensions to an X and Y dimension from these 2 vectors here to each hole would be a lot of dimensions. So a lot of times what they do is they just do, here we go. Center mark, okay, bolt hole circle and circular center line. So bolt hole circle is what we want. Bolt hole circle works this way, 3 or more points. We're going to pick this point, and say that point. That defines the bolt circle center line, and then anytime you want a crossing center line, you pick any other one you want to. Let's get rid of those dimensions. Okay, so again, use your center lines, bolt circle center line by any 3 points, and 4th point because we want a crossing center line through there, say apply. Same thing with here. If you just wanted a bolt circle center line, sometimes that's all you want, circular center line, then you just pick any 3 points and you got that. But we want them going through, so bolt circle center line, this one, and this one. We already have the 9 o'clock and the 3 o'clock hole, the center line going through it, so we only need the top 2 and the bottom 2. What this allows us to do is, if we want to dimension, we could go from here to here. Let's see if we can do that again. We got to go over here to rapid dimension. From here to here. Sorry, that should be angular. There we go. We could put an angle between and put a note on there that said there's 6 of them, and that's how we already defined that there's 6 of them and they're 60 degrees apart, and then we put a dimension on here, basically the bolt hole circle, and square it up. And now we've defined all 6 holes with just a couple dimensions instead of dimensioning every hole individually. So that's how we would. So I want you to put 1 dimension on this part. You could do an overall height or something, just again so I verify that you have it in inches, otherwise it won't turn out. If you did this in millimeters and you put it on an inch sheet, it won't give you a 5.52 diameter for that. Okay, it wouldn't give me a 0.62 height for here. 0.73 height for here if you did it in millimeters and you put it on the inch sheet. So put a dimension or 2 on there just so that I can see that you did it right. And this is how you should hand in this way. Don't forget to change your name and your section number. You should also, save this under a new file. File, save as. Save it in the same folder as your two models, evaporator cover and airfoil. Put them in that same folder under a week 5 folder in your U drive. And then to print it out to email, you say File, Export, PDF. Save this in the same folder, I guess, but then you can email it to me. Okay, that'll create a PDF of this sheet. And good luck on the test this week.